Can you hear me? Ay. Hello? Hello? Yeah, he was dead. All right. So today, I'm going to complete the example on dam free vibration, which we've done yesterday. Not yesterday. Was it yesterday? Tuesday. Then we're going to go into an undamped force vibration. And I hope to finish off mechanical vibration tomorrow by looking at system dynamic response. I hope. Okay, it does not mean I hope it will happen. Okay. Now, I do apologize. Some of you asked me regarding the video on using your calculator to solve equation. So thank you for reminding me. So I have, if you go to the announcement page, okay, all right, you click here, is the same, come on, work. Okay, it's the same video, I mean, it's the same content that you can see on getting how to solve equations with your calculator. Are we clear? So I've posted it already, and without you knowing, okay, I would still prefer you to come to class. Okay, but if you follow the link of this site on YouTube, I've been illegally uploading my lectures on this site. So if you were to happen to miss the lecture because of a term test, okay, okay, but I don't want you all to like, I only see 10 people here, the rest, Eugene's course is okay. 2 days before exam, watch 50 videos and make him sound like Mickey Mouse. We can do it. No, trust me, okay? You won't make it, okay? Because I won't make it. I don't expect you to make it. Are we clear? So I still really appreciate the attendance that you all do still come to class, okay? That is just emergency, or you don't understand a certain concept, okay? You can go back and play the videos. Are we clear? Okay, so how many of you discovered the videos already? Yeah, there you go. Okay. Yes. Ask them. Okay. Yeah, they know how to find it. Okay, they are expert. Okay. But don't rely on it. Okay, it's better to be in class. Okay, it's better to be in class rather than go on those stuff. Okay, trust me. Right. So we are going to continue on the example that we have done on Tuesday. So if I were to draw this out, it's free vibration. It's a mechanical system. We have a stiffness, and we have a damper, and we have a mass. Okay. So we know K is equal to 1250. Okay. Newton per meter. And we know that we have a damper at 200 Newton second per meter. And we know that it's carrying a mass of 9.072 kilograms. Okay. And over here, as you can see, is our boundary condition. So we have two boundary conditions. When t equal to 0, x is equal to 0.15. So for this stage, we always declare, some of you ask me for the question, x positive is always coming down. Any idea why? Because we follow the direction of gravity. Are we clear? So it's coming down, we are forcing it. So anything that is going upwards in terms of displacement, velocity, it has to be what? Negative amplitude. Are we clear? Okay, so there's a question that says that positive is down, just to make things clear. Okay, so the first thing we have to do is we check our c squared and 4mk magnitude. Okay, Why do we need to check that? Because we want to see is our system overdamped, critically damped, underdamped. And for this case, we discovered that our system is underdamped because C squared has a certain magnitude of 40,000. 4mk has a magnitude of 45,360. Okay. So we know that this is our general solution, right? So from here, we have to find the alpha, omega, C1, and C2. So omega, we know that is equal to square root 4mk minus C squared, divide by 2m. And then from there, where we stop, we found that alpha is equal to 11.023 and omega is 4.035. So this is where we stop on Tuesday. Before I carry on, how are you feeling? Are you okay? Are you awake? Yes? No? Okay, here we go. Right, so from here, we have found our omega or omega D. So this time you see it's different. Omega D is damped natural frequency, means there's a damping, okay? Now, if we were, I want to go deeper in this, okay? If it is just omega n, okay, omega n is what? Undamped. Okay, omega n is what? Undamped. If we calculate the undamped natural frequency, which is square root k over m, so this is equal to what? So this is k. K is what? What is k? 1250. And our mass is what? Is equal to 9.072. Right? So when this is the case, so 12500 divided by 9.072, square root the whole thing is equal to 11.73 radians per second. Let me do it again. So it's 1250 square k over m divided by 9.072. Okay, square root is equal to 11.73. Did I got something wrong? 9.02. Okay, so that is the undamped natural frequency that you got. Okay, but we can't use this. Why we can't use this? Because we have a what? We have a damper. So in that context, this is the damped natural frequency is equal to 4.035. Give me a minute. I need to check something before I spread the good news. Okay, hold on. And I remember I wrote it somewhere. It's embarrassing now. It's okay. I'll come back to it later regarding the statement that I like to make. Okay, I used to have it, but not now. Okay, now, coming back to here. Okay, so the next thing that we want to find, so we have a few factors we have found. So x as a function of time. So E is equal to minus 11.023 T bracket, okay, C1 cos omega is equal to what? Do we calculate 4.035 T plus by C2 sine 4.035 T. Okay. So now we are going to impose our boundary condition. So boundary condition number 1 that states where time is equal to 0, displacement is equal to 0. So this is equal to 0. So E minus 11.023 multiplied by 0 bracket C1 cos 4.035 multiplied by 0. And I think I have to put this in a square bracket plus by C2 sine 4.035 and then bracket. Okay. So what we realize now, sine of 0, this is equal to 0. So from here, this is also equal to 1. And cos of 0 is equal to 1. So we know that, oh, sorry, it's not 0. I got it wrong. It's 0.15. I beg your pardon. Okay. So therefore, from here, we know that C1 is equal to 0.15. Okay. Then from here, we differentiate, okay, x dot p. So when we differentiate, we hold. So this equation is what we're going to differentiate. Okay. So it's what we use. What do we use to differentiate this? Is it called product rule? Could you all remember? Right? It's product rule, right? So with this, product rule is equal to minus 11.023 exponential of minus 11.023 t C1 cos 4.035 t plus by C2 sine 4.035 t. And then the whole thing you plus E is equal to minus 11.023 t bracket. So cos to sine, so it's minus 4.035 C1 sine 4.035 t plus by 4.035 C2 cos 4.035 t. Okay, so this is after differentiating. Okay, so from here, we are going to substitute when x dot is equal to 0 at time is equal to what? Time is equal to 0. Are we clear? So from here, oops, I ran out of space. I'm going to copy this. And oops. I'm going to paste here. Okay. So from here, we know that this is equal to 0. And this is equal to minus 11.023 because time is 0. Cos of 0 is 1. Sine of 0 is 0. So it's minus 11.023 C1. And then the next term plus. So this term is 1 outside. Sine of 0 is 0. And this term is 1. So this will be equal to bracket 4.035 C2. Okay. There you go. Okay. So from here, we just matter of doing direct substitution. So we know what is C1 equal to. So 4.035 C2 is equal to 11.023 C1. Okay. So C2 is equal to 11.023 multiplied by C1, which is equal to 0.15, divide by 4.035. So from here, C2 is equal to what? 0.4098. So from here, we can complete our equation. So this is equal to E minus by 11.023 T bracket, okay, 0.15 cos 4.035 T plus by 0.4098 sine 4.035 T. Okay? Okay. Help me find T and let me know what's the value. Now, you have to be really, really careful. Now, tell me if it is negative, okay? Let me know if it's negative. Can you also try? Okay, you remember how to use the, when you're excited to learn that your calculator to do that on your yeah. Yeah, if your calculator says turns off, it's time to buy a new one. So I'm just saying, okay, there's something that you enter wrongly. Okay, there's something that you enter wrongly, not buy a new one. So when we let, okay, when we let the displacement is equal to 0, what will happen? What do you get? Now, by the way, I have not a clue what you will get. Okay, I'm just asking you to do it. Okay, so okay, the first person that get actually my wife is some money in my wallet. Sorry. The first person get it, you get a pint of beer from me, you can get it from ETB 216, okay? Tell me what do you get?